first question is that describe an activity to show that magnetic field lines produced when the current is passed through the circular coil. So the answer is that to study about this characteristic of magnetic field, we have to do a type of a experiment. Experiment consists of apparatus, rectangular cardboard having two holes, thick copper circular coils of different radii and number of turns, key, battery, resistor, and iron fillings. These are the things are present. Now what the procedure is? Pass the coil through the two holes of cardboard in such a way that the half of the loop is above the cardboard and remaining part should be below it, and normally the plane of the cardboard. अब क्या होगा? Iron fillings you have to put on it. So sprinkle iron fillings uniformly on the cardboard and allow the current to pass through the coil, so that by inserting the plug in the key, have to switch on the key, and when the current is going to be started, then the things has happened. So you have to note down the patterns of the iron fillings that emerges on the cardboard after tapping gently a few times. So observation is, place the compass at a point over the pattern of field and you will see the direction of the needle by deflecting
Magnetic
it.
field around a straight conductor. Magnetic field around a straight conductor can be understood by the following activity. Take a flat cardboard and cover it with a white sheet of paper. In the middle of the cardboard, make a hole and through it pass a thick wire and connect the ends of the wire to a dry cell using connecting wires. Plot magnetic lines of force around the conductor with the help of plotting compass. It is observed that the lines of force are in the form of concentric circles. The direction of the lines of force will be clockwise. The experiment is repeated again, but now the current is passed in the opposite direction as shown in the figure. Then the lines of force will be in anti-clockwise direction. If the strength of the current is increased, then the number of lines of force around the conductor increases. This, in turn, increases the magnetic strength.
Now the second question is, list the properties of magnetic lines of forces. So the answer is, properties is the magnetic field line originated from North Pole and the field line become closer to each other near the poles of a magnet, but they are widely separated at each other places. And the third property is that the two magnetic field lines never intersect one another. Okay, why they not intersect with one another? That is the question. Why don't two magnetic lines further force intersect cannot intersect each other? Because due to the fact that the resultant force of a north pole at any point can only be in the one direction, but if two magnetic lines intersect one another, then the resultant force of the in the one section of intersection will belong two direction and it will not be possible in two direction. Now third question is, state the Fleming's left hand rule. See the video and you will get the answer.
Electromagnetism can be a complicated subject, but luckily you can find two of the most useful tools for understanding it right at the end of your arms. Your hands. They help you to write letters, type on a computer, and throw a frisbee. They also help you understand two concepts of electromagnetism. We will use this battery and wire to create a current so that we can illustrate these concepts. While electrons actually run from negative to positive, the convention is to think of electricity going from positive to negative, so that's how we show it here. When current flows through a wire, it generates a small magnetic field around the wire, as shown by these blue lines. If you hold your right hand like so, with your thumb pointing in the direction of the electric current, then the curl of your fingers will show the direction of the magnetic field. This is known as the right hand rule. We need to reverse the direction of the current to illustrate the other concept. We also need a magnetic field to explain what's happening. These two magnets provide that field, depicted here by the blue lines. When charged particles enter a magnetic field, the field exerts a force on them. You can use your hands to find out the direction of that force. Position your left hand like so, with your index finger pointing in the direction of the magnetic field, your middle finger pointing in the direction of the current, and your thumb pointing up, forming a right angle with your index finger. Your thumb shows the direction of the force, called the Lorentz force, exerted on the charged particles. This is known as the left hand rule. The right and left hand rules are two handy ways of better understanding the interplay between electric currents and magnetic fields.
So thank you, students. This is part A, and rest part B will come soon. So part A consists of only this. Thank you, everyone.